looking at sequences. Here you see 1, 2, 4, 6, 8, 10, and we're going to be writing or finding a rule to help us find any term in the sequence down the line. For example, if I asked you, what was the 132nd term in this sequence, you wouldn't want to have to sit there and write out 132 numbers to figure it out. You would like to find a quick shortcut rule, and that's what we're going to talk about. Now this first one's a little easy, so I don't want to know it right away, okay? But we got some other things to build up to. First of all, there's some vocabulary we have to consider. The term is defined as each number in the sequence.
Why did you put three lines after term?
Because that means defined as. So term has a little bit different definition here than it did with an algebraic expression. Here, terms refer to the actual numbers in the sequence. So 2, 4, 6, 8, 10, those are all terms of this sequence. All right, so I could go right here and I can say, these are the terms. All right. The next thing is term number. The term number is the position. Actually, I'm going to change that and make it a little bit more specific for you. I'm going to say it's the numerical position of each term. So I can go and on top of my sequence over here, I can write in the term numbers. This is term 1. It's in the first position in the sequence. This is term 2. It's in the second term in the sequence. The 6 is term 3, the 8 is term 4, the 10 is term 5, and we could keep going out to some term n out in the distance. So the term number just refers to the position that that particular term holds in the whole sequence. The fifth term is 10. 1, 2, 3, 4, 5, it's the fifth term. It's the term number. All right. Next is the nth term. The nth term is some unknown I should say I got stuck. It's the nth term is, yeah, no, that's right. Some unknown number out at position n. So some number out there. It might be 81st position or the 67th position or the 1000th position. The nth term is whatever goes with the one in the n position. Daryl?
Wouldn't the number have to end in th? So could we eliminate like first? First, second.
What do you mean?
Like, since it says nth term, it could be the 10th term,
12th term, 15th term.
It could be like first.
It could be like the 81st term or something, but we just call it the nth term. It's just a general statement, general vocabulary. Yes, Ruth?
So if you wanted us to find the 132nd number for the sequence, if you look at the term numbers, 1 times 2 is 2, 2 times 2 is 4, and 3 times 2 is 6.
Okay, yeah, we're going to come to that in just a second. You see a good pattern, and we're going to write it in just a second, so I'll come back to you.
Okay.
All right, but first I want to define this formula for the nth term is what our goal is today, and that is just really an algebraic expression that gives a rule for finding the nth term. Okay. right, so we're gonna practice on this sequence I gave you, the 2, 4, 6, 8, 10, and Will and Luke have already kind of indicated they see a pattern, right? Luke said if I can take the term number 1 and multiply it by 2, I get the first term. If I take 2 and I multiply it by 2, I get the next term. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So what would be an expression for the nth term? What would you say the nth term would be as an algebraic expression? Will? 2n, he said sensitively. Let's see if that makes sense. That means that for any number in this sequence, if we take its term number and we multiply it by 2, we get the right answer. So this is the first term. When I multiply it by 2, yeah, I get the first term here. Let's skip and go to 4. If I take 4 and I multiply it by 2, I get 8, which is that term. So yes, 2n is correct, and that is called the formula for the nth term. That's what we're looking for today. Now this one is kind of easy, and we'll see different variations where you have to think and work a little harder. Why would we want to do this? Well, as we get into problem solving, sometimes you'll see the first couple numbers, and then the problem will ask you like about the 101st one. And you don't want to have to go through every single iteration to figure out 101. You would like to be able to find a quick shortcut, and finding the formula allows you to do that. This is the power of algebra. Yes, Jack?
If the number, like if the pattern is doubling, then would the formula be n squared?
That's a good question. So if it's doubling, like 2, 4, 6, 2, 4, 8, 16, that's not squared.
Oh yeah.
Those are actually powers of 2. And we'll look at some of those. Today, though, they're all more linear. They're kind of constant up bys. Daryl?
If we were to take the first line off on the loop, and it would still be the same thing, right? 2, 4, 6.
Yeah, this is the sequence we're working with. These just number their positions. Those are just what position each one's in. Okay. All right. So let's move on and start to look at things that look a little more interesting. Okay, so here's another example. Write this one down. What's the formula for the nth term of 1, 3, 5, 7, 9? I give you a couple blanks to fill in, so it's kind of like everyone has a place to start without being overwhelmed. So do you know the next two numbers in the series, Jack?
11 and 13.
11 and 13 are correct. But that doesn't give us the actual formula. We got to figure it out yet. You have a question, Jack?
I think I might know what the formula is.
Okay, I want you to just jot it down in the margin, and I want you to check and see if you're right. You too, because Will, you have an idea, right? All right, let's build this a little bit. I want to give you guys some strategies to help you figure this out, okay? So you see I have hints to uncover the formula here. You should all write that on the side of your paper. I'm going to give you a couple of hints that will help you. All right. First of all, what you should always ask yourself is how much is it going up or down by? How much is it going up or down by, Caitlin? 2. It's going up by 2. The last sequence went up by 2 also, right? All right. Those last numbers, 2, 4, 6, 8, in the first sequence on your paper, right? We talked in chapter 1 about number theory stuff, and we talked about factors, but we also talked about, what's the other thing we talk about a lot when we talk about factors? We also talk about multiples, yeah. 2, 4, 6, 8, 10, those were multiples of what? 2, 4, 6, 8, 10 are the multiples of what number? Mary? 2, all right? And they go up by 2. Multiples of 2 go up by 2. Here again, this sequence is going up by 2. That's kind of your hint that this is about multiples of 2 as well. They're just shifted off of the pure multiples, okay? So this is going to give you, when you look at this, then that kind of should make you think, there must be multiples of 2 buried in my formula. which means I probably am gonna see a 2n in this formula because they keep going up by 2, right? That's the first thing to ask yourself. The next thing you wanna ask yourself is, how does each term compare to the multiples of 2? Because I figured out that we got multiples of 2 going on in here. Then what we want to do is we want to ask ourselves, how does this new sequence compare to the straight multiples of 2? Because I got the up by 2 thing going on, I think that this is multiples of 2. You want to compare it to the straight multiples of 2. Caitlin, what did you want to say?
I was just wondering if it meant like if it's added and multiplied by 2.
Is that this question right here? Yeah, here's what I want to show you. What I mean is, how does each term individually from this one compare to that one? So how does the first term in this up by 2 sequence compare to the first term in this up by 2 sequence? And do you see this one comparing to this one in the same way? How does 5 compare to 6? How does 7 compare to 8?
Oh, I was so
Robbie? Is this one higher? It's one lower, right? It's one lower. It's minus 1. So if I work my way out here to the nth term, right, I've got multiples of 2, but the sequence is shifted down 1. So the formula,
2n minus 1?
2n minus 1 seems like that might make sense. But you don't want to just put your answer down and stop. You want to check and see. Okay, so how do we check and see? First of all, let me erase some of these circles. All right. So this is what we do to check. Remember, this is term 1, term 2, term 3, term 4, term 5, 6, 7, and term n out here. So to check it, if Robbie's right, or Luke's right, and 2n minus 1 is the formula, we can test it by testing any one of these positions. So for example, if this formula is right, when I plug in 6, I should get the 6th term of 11. So let's try using term number 6. I plug it in here. Two times 6 is what, Will? Minus 1 is 11. Is the 6th number 11? It is. It is. Let's try another one. You always want to test at least 2 to make sure you're on track. What position do you want to test? Pick a number you want to test. Caitlin?
5.
5. So let's try the 5th position. Let's try when n is 5. What would you expect we should get as the answer when we try n is equal to 5, Winky?
9.
Right, because the 5th number is 9. So we plug it in to our 2n minus 1. 2 times 5 is 10, minus 1 is 9, it works. So you guys did find the formula for the nth term, 2n minus 1. So if I asked you what the 22nd term in the sequence is, what would you do, Jack?
Multiply 22 times 2 and then subtract 1, so it's 43.
Yeah, it's 43, and we didn't have to list them all out until we got there. See how much time that saved us? Yes, Liam?
I don't care how we did that.
Okay, well, let's do some more. Okay. All right. So these questions right here are key. We're going to keep coming back to them. All right. So here's a new sequence. 4, 8, 12, 16. Comma. Question. So the nice thing is you can always fill in the next couple. That'll make you feel good. Right? So what are the next couple numbers in this sequence? Next couple numbers. Anna?
20 and 24.
20 and 24. All right. I always take a minute to write in my term numbers up above them, because sometimes that really helps. And we're looking for the nth term somewhere out there. All right. The questions, yes, Erna?
I don't get what the term numbers are.
They're these up here.
Yes.
They're the position that it's in. Now, this 4 is the first number in the sequence. The 8 is the second number in the sequence. See what I'm saying?
Yeah.
All right, so we got ours. What's the first question we're supposed to ask ourselves? What's the first question? Daryl?
How does it compare to 2, 4, 6, 8?
Oh, not quite. What's the very first question?
How much is it going up or down?
Yes, how much is it going up or down by? What's the up or down by this time? Michael?
4.
4. This one's going up by 4. This is different than the last two sequences we looked at, isn't it? So now we want to throw those out of our mind. This is up by 4. We're not looking at multiples of 2. What are we probably looking at? Robbie? Yeah. We got multiples of 4 going on here because they're going up by 4. So you should think, multiples of 4, algebraically, what does that mean? Caitlin? 4n. So we probably got some 4n thing going on here. Now the question is it just straight up 4n? Are these just the multiples of 4, or are they shifted away from it? Mary? It's just 4n. If I take 1 and multiply it by 4, I get 4. 2 times 4 is 8. 3 times 4 is 12. 4n it is. Check and make sure. 6 times 4 is 24. This is straight up multiples of 4, aren't they? 4, 8, 12. 4 times 1 is 4. 2 times 4 is 8. These are just the straight multiples of 4. Leah?
I don't get why it's like the with n. Can it be any number? I mean, there's like.
Well, we're looking for a general rule, so no matter what I ask you about, whether I ask you about term 62 or term 1059, you can use this formula. This n is representing whatever position I ask for. All right, now let's complicate it a little bit and make it more interesting. All right, so here's our next one. 6, 10, 14, 18. Yes, sir.
I just have a question. Now on tests and things, when they ask us to pick our own, give our own variable, should we not use n?
No, you can. It doesn't
Okay.
matter. That's a good question. All right. So here's our sequence: 6, 10, 14, 18, blank, blank. I always go for those blanks. Those are nice ones. Liam?
22, 26.
22 and 26. Liam, you must have already figured out what this goes up or down by to do that, right?
It's up by 4. So it's 4 and plus 2.
It's an up by 4, which means it's 4n and something, right? It's not just the straight multiples. Liam, you said 4n plus 2.
Yeah, how come? Because if you look at the starting, or the first term,
Uh-huh.
the sequence,
Uh-huh.
it's 6, which is, but it's still like up by 4, so it's got to be 4 and plus 2, because 4 plus 2 is 24.
Okay, all right, so he kind of intuitively saw that in a way. Here's what I would say to everyone else, and when you look at these, ask yourself, remember, how does this number compare to the straight multiples?
Minus 2.
Well, this one is plus 2, right? And how does this compare to this? Plus 2. How does this compare to this? Plus 2. So Liam was right, 4n plus 2. Well, we think, but we should always check.
Yeah.
We should check. So, Erna, pick any number up here, and we're going to test and see if we get the right one. So which one do you want us to try?
Wait, what?
We're going to test and see if this works as a formula for any one of them, right? So the way to test it is to pick one of these and put it into the formula. Which one do you want us to test? 5. So just try n equals 5. We want to see when we put in 5 if we get the fifth term out. So if Liam's right, 4n plus 2 is the formula. When we substitute in the fifth number, plus 2, we should get our answer. And we do, it works. All right, so now I have one for you and your partner to try together.
Can't you just take,
Which, yep,
could you take, 6, wait, take 4, because it's up by 4, and then to one of those multiples, so say 5 again,
do what?
4 times 5,
It's 20,
oh, it's,
right?
Never mind.
Yeah. Okay, so here's what the one I want you and your table mates to try. 1, 5, 9, 13. Fill in the next couple, ask yourself what they're going up by, and then how do these compare to the other to write the formula. Okay, so we're checking back in. What were the next two numbers you filled in, Kaylin?
17 and 21.
And what did you find is going up by? So we're up by 4 again. So it means we're probably looking at multiples of 4, right?
But they're not straight multiples.
Right.
It's 4 minus 3, because 4 minus 3 is 1. That's the first one.
Okay, so Caitlin did a good job. Their table, look at each one of these and see how it compares to the straight multiples. Oh, it's down 3 from it. So 4n minus 3 is correct. Each one of these numbers in the sequence is 3 less than the straight multiples of 4. Remember, these are the term numbers that you can write in if you need to. Which one do you want us to check? We need to check one. So should we check, Mikey? Let me check 1, 2, 3, 4, 5, or 6. 6. Check 6. All right. If this formula works, what should we get when we put 6 into this formula? If it works, what should we get? Mikey? 21, right? So 4 times 6 minus 3. 24 minus 3 is 21. It gave us the right number, right? Very good. Check. All right. This is nice. We have time for you to practice on one more. These were all multiples of 4, so you might have been expecting that. I'm going to give you one you don't know.
Example 4. Let's go with 8.
Let's go with 14. Here we go. Try this one. It's a good process here. I heard kids going, it's going up by 7. So that means we've got hidden multiples of what, Anna?
Yeah.
Oh. Well, since it's going up by 7, what do we know we're probably looking at? 7 and something, because the multiples of 7. So then you come over here, and you should be comparing them then to the straight multiples of 7. The first multiple of 7 is 7, and the next one is 14. How do each of these terms compare to those straight multiples? Anna?
7 plus 1.
7n plus 1, she says. How come?
Because for 15, we know that 7 times 2 is 14, and then you get 15 back.
Oh. You're comparing it to 14, but is 14 the first multiple of 7?
No.
No. First multiple of 7 is 7, and then it's 14, and then it's 21, and then it's 28. How do these compare? Not plus 1, but what, Vaishu? Plus 8. So it should be 7n plus 8. And that if you check it, you should get it. All right.